Hello, my name is Brandon, and I'm here with Sean, James, and Dhruv here. And we're going to discuss our report on analysis of security issues in a microservice architecture. Starting off, we're going to discuss what a microservice is. A microservice is an architectural style that structures an application as a collection of small, autonomous, and loosely coupled services that work together to deliver a specific functionality. Each microservice is designated to perform a specific task or service, and they communicate with each other through well-defined and lightweight protocols, such as HTTP or messaging systems. The concept of microsystems emerged as a response to the limitations of monolithic architectures, where the entire application is built as a single unit that runs on a single server or set of servers. In a monolithic architecture, any change made to one part of the application affects the entire application, making it difficult to scale, update, and maintain. One of the main benefits of microservices is the ability to improve scalability and performance on the application. In a monolithic architecture, the entire application must be scaled up or down based on the demand, even if only a small part of the application is under load. In a microservice architecture, only the services that are under load need to be scaled, which reduces the cost and complexity of scaling. Microservices architectures offer several key benefits over monolithic architecture, including scalability, which are microservice architectures allowing for individual services to be scaled independently, providing greater flexibility and efficiency in handling variable workloads. This means that resources can be allocated only where needed, reducing cost and improving overall system performance. Resilience. Because microservices are isolated and independent of each other, failures in one service do not necessarily affect the entire system. This makes the architecture more resilient and fault tolerant, as issues can be isolated and addressed without disrupting the entire application. Flexibility. With microservices, developers can choose the best technology stack for each service based on the specific requirements of that service. This allows for greater flexibility in choosing technologies that fit the case rather than being limited to a single technology stack for the entire application. Agility. Microservices allow for faster and more frequent releases of new features and updates. A service can be developed, tested, and deployed independently of each other. This reduces the time required for testing and deployment, allowing for faster innovation and greater agility in responding to changes on the market. And maintainability, because microservices are smaller and more focused on monolithic applications, they're easier to maintain and update. Developers can work on individual services without disrupting the entire system, making maintenance and updates more efficient and reducing the risk of errors and bugs. Our problem statement for our research project is the gap between the implementation of microservice architecture and the knowledge of security posed. For this, we will discuss the following: research and mining techniques, sentiment analysis, topic modeling on datasets of microservice-related posts from Twitter, security issues and resolutions for those issues. We'll also discuss analysis of impact it may or may not have had on the perception of the microservice practitioners and the organization. Objectives. The rise of microservice architecture and software development has led to new security challenges, particularly the risk of data breaches that can harm companies and their customers. Due to this, it is essential that we know what the top microservice security incidents happened in the past and the impact caused. Below, you will find our research questions. 1. Identify major microservice-related security incidents from the historical records of the CVE project. And 2. Analyzing the impact of the microservice-related security issues, data breaches, and their impact on user sentiment and subsequently on the stock market. Understanding the relationship between the microservice-related security issues and user sentiment can help companies to develop effective security measures, protect users' privacy, and maintain user trust. The finding of this research can also contribute to the development of best practices and guidelines for microservice security and privacy, which can benefit the wider software development community. Ultimately, this research can play a significant role in improving the security and privacy of microservices and reducing the risk associated with their use. Our motivation. The increase of microservice and modern software development is a huge motivation. As more companies adopt microservices, the risk of data breaches and their impact on both the victim company and its customer increases. Consequent emergence of new security challenges and understanding the microservice-related security issues like cost of data breach and in microservice is crucial for companies to evaluate the true impact of these security incidents and to develop effective strategies for prevention and mitigation. So to aid the current guidelines and knowledge on secure microservice systems design and implementation, and to contribute to the development of best practice and guidelines for microservice security and privacy, benefiting the wider software development community and reducing the risk associated with microservice use. And here our methodology, where we also discuss data collection methodology. One, we have secondary data collection. Secondary data collection is a method of data collection from a pre-existing source, more often used when it is not feasible or cost-effective to collect primary data, or when existing data can provide variable insights for a research study. Secondary data collections involve collecting and analyzing data that has already been collected by other sources, such as researchers, organizations, institutions, government databases, academic literature, market search reports, and social media data. For our research, we use the MITRE CVE projects database to identify microservice-related security issues and the organizations that were impacted. And two, we have web scraping. Web scraping is the harvesting of data from websites through the use of HTTP or a web browser. To get the data required for sentiment analysis, a suitable source of public sentiment reasonably accessible through automated means, queryable and classifiable, was required. Twitter was chosen for our data for a variety of reasons. It's easy to access, it's used to spread opinions, and information is readily scrapable through its search feature. Now I'm going to pass it on to JJ, and he's going to discuss further.
Thank you, Brandon. So we went through various phases to get through our data analysis in this project. We chose sentiment analysis, looking at trends in public opinion as hack data was released to the public by the victim companies. Went through a number of steps. First, we started with data collection. As Brandon said, we are going to be scraping the data from Twitter. We went through training a classifier, tokenization, data cleaning and lemmatization, and finally we classified each tweet as positive or negative using a naive Bayes classifier. In the data scraping step, we used the library SNF scrape. Once again, we chose this for its ease of use and ready interface. SN scrape is both a library and a command line application, takes a number of arguments, can itself be easily automated. The command line feature was used for this research, and a script in Python was written to create a Unix style shell script. All in all, we used a number of switches. As you can see in this code, the operative line is the script line, which generates a single command line thing. Takes SN scrape, creates a JSON file, max of 50,000 tweets since a start date with a particular search term. Monday.com is the example here, and then throws everything out into a JSON file. After that, we needed to train the model. So in machine learning, in order for a classifier to make decisions, it must first be taught how. In this case, it has to be taught what a positive tweet looks like and versus what a negative tweet looks like, in order to properly differentiate unseen examples. To do this, a number of known examples from a sample data set are shown to the model. In this case, 7,000 of each, positive and negative. And through the process of tokenization and lemmatization, which we'll discuss later, the machine learning model learns what makes a tweet positive or negative. This process also looks at stop words or words that should be ignored in classification, removes them from the sample. This is using a standard database of stop words. Well, we'll get to that in a second. Go ahead. So after we get in the tweets from, or after we train the classifier, we're going to get the tweets in and we're going to tokenize them. Tokenizing is a natural language processing step where individual words, groups of words, phrases, or sometimes even symbols are separated and classified into something called a token. A sentence may contain a number of tokens separated by white space in the case of individual words, or returned by a tokenizer, which is what we actually used. After that, we cleaned and lemmatized the data. Cleaning removes as much extraneous information as possible and looks at a sample to get a good classification. This code looks at each token and removes punctuation and stop words before feeding the lemmatizer in the next step. Lemmatization is the process of changing each word from its conjugated form to its root form for use in natural language processing. The process that we use is something of a black box in nature for this, but you can see that in the fourth line from the bottom. It's just calling a word lemmatization library. After that, we did some classification. The classifier for a two-class system or binary classifier using the naive Bayes base model to differentiate positive from negative tweets. Naive Bayes is it's essentially a theorem given by the following formula. Probability of A given B is the probability of B given A for two events A and B multiplied by the probability of the first event divided by the probability of the second. Yeah. And finally, we return this to the classifier. The classifier in this case takes each tweet, tokenizes, lemmatizes, cleans it, comes back, classifies it as positive or negative, and then it's simply a matter of determining whether the day's results were positive or negative on the whole. So we take all the tweets that were created on that particular day, get a percentage that were positive, and return that and graph it out in the next steps.
Thanks, JJ. So we're going to be looking at some of the hacks that we discovered through our research. One of our biggest hacks was the Tesla Kubernetes attack. In 2018, this attack occurred. That's an example of a potential security risk associated with Q8, an open source container orchestra system in a production environment. In this attack, a group of hackers exploited vulnerability in Tesla's Q8 system to gain access to an Amazon Web Service account that contained sensitive data. The vulnerability was tracked in a CVE. This vulnerability was discovered in December 2018 and affected versions 1.0 through 1.12 of Kubernetes. It allowed attackers to bypass certain security mechanisms in Q8 and gain access to sensitive data stored on the system, also known as privilege escalation attack. The vulnerability was caused by a flaw in the Q8 API server, which is used to manage the Kubernetes cluster. Once the attackers gained administrative access to the Kubernetes system, they were able to deploy their own containerized application within the system. From there, they were able to launch further attacks to gain access to Tesla's Amazon Web Service account, which contains sensitive data and system configurations. And this is some of our data that we saw in our graphs. And one of the key takeaways from Tesla Kubernetes hack is the importance of securing API, which is a critical component of Kubernetes system. To prevent attacks like this one, it is important to ensure the API service is properly secured and that access controls are in place to limit who can access it. So here we can see the positivity over time with Tesla with trending downwards, and yeah, and this is the market evaluation during that time. Another hack was Twilio AWS breach in 2021. Cloud communication platform Twilio announced it has experienced a security incident that led to unauthorized access to some of its customers' data. The attackers reportedly gained access to one of Twilio's AWS accounts by exploiting a misconfigured AWS identity and access management role. The attackers gained access to a single AWS account that was used by Twilio to store internal data. The AWS account was reportedly secured with MFA mechanism, but the attackers were still able to gain access to the account by exploiting a misconfigured IMA role. This misconfiguration allowed the attackers to escalate the privilege in the AWS account and eventually deploy their own code through a modified version of the Cloud Eye. It's an open source tool which allowed them to extract data from the account. The data was stolen, including certain API keys, credentials, and other sensitive information that could be used to compromise the security of Twilio's customers. The attack occurred over a 5-hour period in 2021. And this is some of our data analysis, our tweet positivity over time. You can see that the relation, the trend was neither positive or negative. And then you can see here in that frame of the stock market, it was able to rise, but it eventually go down again. Okta IBIS breach. There was a vulnerability with the email server names, addresses, and authentication tokens. The attack vector was social engineering and phishing. Remediation was the company had implemented several security measures to prevent similar attacks in the future. The tweet positivity over time was trending upward, and the stock had briefly gone down, but was able to recover. Security breach at Monday.com. This breach occurred in 21, involved unauthorized access to the company's internal systems, which resulted in the theft of user data. The incident was caused by a vulnerability in the company's microservice architecture, which allowed the attackers to gain access to sensitive data by allowing them to bypass authentication. The vulnerability that the attackers exploited was identified as CVE, server-side request forgery vulnerability in the Jira Software Cloud app. Monday.com reported quickly to the breach, taking steps to contain the attack and secure its systems. The company also notified its users of the breach and advised them to change their passwords and be vigilant for phishing attempts. The Monday.com breach serves as a reminder that even the most well-designed and secure systems can be vulnerable to attacks due to security issues in one of the third-party components. Here, Monday.com went public after the hack, so therefore we had no stock data. And our tweet positivity over time, the trend was downward. Another hack was HashiCorp breach. Vulnerability was user accounts. The attack vector was a 0-day attack, which was tracked in a CVE, and it was rated as critical. The remediation was HashiCorp quickly responded to the breach by taking infected systems offline, launching a comprehensive investigation. The company urges customers to reset their password and enable two-factor authentication as a precautionary measure. Again, there was no, this company was not public at the time of this hack, so we couldn't have that data. And tweet positivity over time, you can see the trend was in a negative direction. And then the last one here is our Confluent phishing attempts or Confluent phishing attempts. The vulnerability was authentication among authenticated users into the notification service. The attack vector was social engineering and phishing, and the remediation was engaged with a third-party security firm to conduct a forensic investigation and to assist with their remediation efforts. Again, Confluent went public after the hack, so we could not retrieve this data. But the tweet positivity over time, you can see the trend was slightly downward. And that will bring it to Drew.
Thank you, Sean. So coming over to the overall results of the entire data analysis project that we ran, although the premise seemed sound when the research questions were created, that public sentiment would decrease rapidly in the aftermath of a disclosed breach, that stock prices would fall, and that recovery would take some time. This hypothesis is not supported by the extracted data. Sentiment does trend down slightly in the month following an attack, in most cases, notably except Okta, which we have yet to identify an exception for the upward trend. In many cases, the lack of sharp downturns may be explained by the fact that these companies are not discussed much in the Twitterverse. For instance, there are only 547 total tweets about Confluence in all of Twitter over the entire month for which we collected the data for. In contrast, there are 325,481 tweets about Tesla for that same period. There may be other factors at play as well. Company damage control, public relation techniques, or misdirections might play a role as well. But these factors are beyond the scope of this project research. There are several best practices as a learning from these hacks that we saw. To prevent these attacks like the ones listed above by Sean, it is important to take a comprehensive approach to security in a microservice-based architecture. And this includes implementing a strong access control. Access controls are a critical part of any security strategy, and they are especially important in a microservice-based architecture. By implementing role-based access controls and other authentication mechanisms, you can limit the scope of any potential attacks. Next is securing APIs and network connections. Sean, can you go back to the previous slide, please? Yep, securing APIs and network connections. Because microservices rely heavily on APIs and network connections, it is important to ensure that these connections are properly secured. These can include using encryptions to protect data in transit and implementing strong authentication mechanisms for API endpoints. Regular testing and updating security measures, because security threats are constantly evolving. It is important to regularly test and update your security measures to ensure that they are up to date and effective. This can include performing regular penetration testing and vulnerability assessments, as well as staying up to date with the latest security patches and updates. There is also a dire need for monitoring for anomalous activities. By implementing robust monitoring and logging mechanisms, we can quickly detect and respond to any anomalous activities in our Q8-based systems. This can include using tools like intrusion detection systems, security information, and event management SIEM systems to help identify potential security threats. Robust incident response planning. Organizers must also have a robust incident response plan in place to quickly respond to security incidents and minimize the impact on users. This should include regular training and testing of the incident response plan to ensure it is effective. And finally, timely patching and vulnerability management. As more organizations move towards containerization and microservices, it is important to ensure that all components of the infrastructure are kept up to date with the latest security patches and updates. Next slide, please. Some of the key security challenges in microservices include authentication and authorization. In a microservice architecture, each service must have its own authentication and authorization mechanism to ensure that only authorized users can access it. However, this can lead to inconsistent security policies and vulnerabilities if not properly managed. We also saw major issues with communication security. The communications between microservices must be secure to prevent eavesdropping, tampering, and unauthorized access. This requires implementing secure communication protocols such as SSL, TLS, and encrypting the data in transit. Data protection. Because microservices are distributed across multiple servers, it can be challenging to ensure that confidentiality, integrity, and availability of the data they process. This requires implementing strong data protection measures such as encryption, access control, and data backups. And finally, compliance. Organizations must ensure that their microservices comply with relevant regulatory requirements such as GDPR, HIPAA, or PCI DSS. This requires implementing appropriate security controls and auditing mechanisms to demonstrate compliance. Next slide, please. Finally, the conclusion. The use of the microservices also presents several challenges, particularly in terms of security, because each service is developed and deployed independently. It can be difficult to maintain a consistent security posture across the entire application. Additionally, the distributed nature of microservices can make it challenging to ensure secure communication and data protection. Microservices are an architectural style that offer numerous benefits such as scalability, flexibility, and ease of maintenance. However, there are numerous security challenges that needs to be addressed to ensure the protection of sensitive data and resources. By implementing appropriate security measures and best practices, organizations can reap the benefits of microservices while minimizing the risks. Next slide, please. Lessons learned. So there are a few lessons learned from this project. We have formulated these in pertaining to by creating a few questions and answers. So what are the few pressing issues and what are the stats pertaining to these issues? According to a survey by API management company Com, 79% of developers say API security is a significant concern for their organization. A report by container security company StackRox found that 90% of the organizations use container in production, but only 35% believe they have adequate container security measures in place. A report by security firm Trend Micro found that 86% of the organizations have suffered a security incident related to their cloud environment, which can include microservices running in the cloud. Where is the focus in this project? The focus is on examining the security challenges associated with microservices architecture and provisioning insights and mitigations. We would generally say as a group that the focus on this topic is in the right direction, where organizations are constantly striving towards achieving more secure microservice architecture-based environments. Next slide, please. Next, we discuss about the government policies and open research areas. So government policies documents that discusses this topic. There are several government policy documents that discuss security issues in microservice architectures. One of such documents is the NIST Special Publication 800-204, which provides guidelines for security cloud computing architectures, including microservices. It provides guidance on various components such as API, containers, identity management systems, etc. It also emphasizes on risk management and ongoing monitoring. There is another document called Cloud Smart Strategy issued by US Office Management of Budget for Budget in 2019, which emphasizes on the need for strong security measures in cloud environment, including microservice architectures. It also talks about risk-based approach to security to utilize existing security frameworks and best practices. There are several open-ended research questions in the field of microservices-related security, and a few of those are that how can we ensure secure communications between microservices components in a distributed system without sacrificing performances? And another one is how can container security and isolation be improved to prevent container escapes? And how can the effective attack surface be reduced? Moving on to the challenges that we faced as a group implementing this data analysis project, we came across multiple hurdles during the course of the project, some of which are listed below. The initial proposal to extract the data from Stack Overflow to identify the microservices-based security issue had to be dropped due to very limited number of posts on Stack Overflow pertaining to security of microservices. During the last week of the attack, we also faced an issue where the web scraping tool that we were using, the SNS scrape, was blocked by Twitter, and therefore we were not able to pull any fresh data during the last week of the project. A few of the organizations that suffered major security breaches on microservices were also not publicly traded companies, so the data of stock market was not available during that period. And we also expected a public reaction post security incidents with the rise in negative sentiments. However, there was little to no impact at all in the user sentiments as well as the financial trust of the users with that company. That clearly indicates that there is a huge gap between the user awareness versus how the security of these organizations is maintained. And there is a dire need for users to start following closely the security and take ownership of their own security and privacy. That being said, here we have listed all the references, and that concludes our presentation for this project. Thank you so much for listening and have a great day.